Hello, everyone. So we're going to start another webinar series. And this series is a memorial for Robert Crapo. And the ATS, our assembly, the respiratory structure and function award that award the best scientists and that innovate in our field in how to measure lung functions or lung structure. And today we have Dr. Gerald Zavorsky, who got an award at ATS 2026. Ridhima?
Yeah, so it's my honor to introduce Dr. Robert Crapo Memorial Innovation Methodologies Award. The award highlights the achievement of Dr. Crapo, an international leader in pulmonary function and diagnostic research. It also advances our understanding of importance of lung function testing. The award honors Dr. Crapo by recognizing a mid-career researcher who is developing new techniques that shows the potential for enhancing our understanding between respiratory function and structure. It is also my honor to welcome Dr. James Crapo, brother of Dr. Robert Crapo, who would be offering introductory remarks for his brother's legacy on respiratory medicine. So over to you, Dr. Crapo.
Thank you. It's a real honor to tell you about my brother. My computer has a glitch, so I can't show you some slides of his pictures of him, but I can tell you about him. My brother Bob is 2 years older than I am. We come from a family of 6 children that grew up in Idaho Falls, Idaho, and I always adored him and followed him. And in fact, when he decided to go to medical school, he went to the University of Rochester, and I followed him there 2 years behind him and joined him there for medical training. Now, when we had wonderful times together in learning basic medicine, but he left there it was during the Vietnam War. He left there to go to University of Utah to train in, and he thought he was going to train in anesthesiology. So he signed the Berry Plan, which was important to everybody at that time, and went there to do general medicine to start his internship at the University of Utah. And in the process, he fell in love with critical care medicine and pulmonary disease and changed from anesthesiology. Now, what the Navy did was immediately to draft him and put him on a ship as a ship's doctor for 2 years in the South Pacific. And meanwhile, I continued training in the East Coast, and he came back to the University of Utah, and we both trained without talking to each other, and both decided independently to go into pulmonary medicine. And we were delighted when we found that out. It was interesting because Bob's first assignment as a faculty member at the University of Utah was to be in charge of the pulmonary function lab at the affiliated hospital, the International Health Systems Hospital there. And he applied total rigor to that. It was just the beginning. We were just beginning to have pulmonary function materials, tests, and equipment, and computers. And his biggest problem was that there were no standards. And no one knew what normal was. And I'm talking about late 1970s. So he studied about 250 people that were normals from sea level to altitude and published that in a series of papers in the early 80s and eventually published it in a book that I'm going to hold up, you can see. This is a book that I treasure. The Bob is the second edition of it, published in 1984, and it gives all the pulmonary function standards for both gender, height, and age, and became a standard in the business. It was the first one for almost 10 years, the first and only one out there for standards, and so it was used worldwide. And it's interesting that what happened is that every company then incorporated his standards into their equipment to report percent predicted for all the pulmonary function tests. And at the bottom of every pulmonary function test in the world in the early 1980s had the word Crapo, C-R-A-P-O, just to show that its standards came from him. And I had the experience of getting asked to give lectures in rural parts of North Carolina or Virginia, and having people come up to me and say, my pulmonary function machine is named after you. And Bob and I were consistently confused. And I was doing cell biology and he was doing pulmonary physiology. And he was invited to give lectures internationally in cell biology, and I was invited to give lectures in physiology, both of which were kind of funny. So we decided to work together. Now, Bob's actually, his pulmonary function tests, good ones have come out since that time, great ones, and he played the role of chairing the ATS committee on standards, which is the reason why this lecture, I'm sure, is supported by him. But we decided we had to publish some papers together just to prove that there were two of us. And we did that by studying dogs. We went to his laboratory and looked at dogs, and he measured all of the physiology, diffusing capacity in the dogs. And then we fixed the lungs, and I used my skills with pathology and Eval Weibel's morphometric techniques for measuring capillary volumes and surface areas and diffusing capacity to compare a physiologic and a pathologic measurements of diffusion capacity. And we published that in 1981, 1982, with both of our names on it. That's kind of our story. That what's really amazing is that his study, this is from 1984, that's still appropriate, it's still correct. And that's amazing that something has lasted 45 years like that. And so it's a real honor to tell you about him. Now, he died of Alzheimer's disease about 10 years ago, but his impact is still felt worldwide of demanding excellence and standards and quality to do pulmonary physiology. And I would just say that with all of our interest in diffusing capacity, which was one of the most interesting and challenging elements, he would be excited to join the lecture today to hear Dr. Zavorsky talk about new technologies using double diffusing techniques. So with that, I would say I honor him. I'm pleased to honor him and very excited to hear the lecture.
Well, all right. All right, let me introduce our, awardee for this year, Dr. Gerald Zavorsky, who got the Robert Crapo Memorial Innovative Research and Methodologies Award. And he did his Bachelor of Science Respiratory Care in the Loma Linda University. After that, he attended a PhD program in experimental medicine at University of British Columbia. And on top of that, he also have degrees in kinesiology at McGill University. He published many different papers related to the lung function, especially for gas diffusion, and especially in the last years, establishing standards for gas diffusion in the lung for patients that have a heart failure and the post-COVID lung injury. He's professor at UC Davis, where he practiced as a respiratory care practitioner, and will be very grateful to introduce Dr. Zavorsky, that's going to present his talk about the double diffusion technique in predicting classifying disease.
Thank you very much. I really appreciate being here today. Let me share you my presentation. Here we go. Right, so thank you very much. I'm at UC Davis, and I am very, very happy to be honored today for this amazing award. I know there was been a brief introduction about Dr. Robert Crapo. His brother just gave a talk 2 seconds ago and introduced me, which was very nice. Dr. Crapo trained at Brigham Young. Then later he joined the University of Utah, and he worked very closely with the American Thoracic Society back in the 80s and chaired proficiency standards. And basically, the memorial and this award is really due to his central role in developing reliable standard pulmonary function testing. And, I've been trying to aspire to do the same in my career. And sadly, Robert Crapo passed away about 10 years ago due to Alzheimer's disease. And so we are honoring his legacy today. And I'm really appreciative of receiving the Robert Crapo Award from ATS for 2026. So before we begin, there are many journals out there, but one journal that has just started is called Pulmonary Function Diagnostics. And if any researcher out there has manuscripts related to pulmonary function diagnostics, I encourage you to submit. It's an open access journal. It's double blinded, and it is free to publish until 2027. This journal will hopefully be indexed in PubMed after we receive a significant number of articles, somewhere around 25 or so. So, okay, let's move on. Topics to discuss for today. I think before I talk about classification of and predicting cardiopulmonary disease with pulmonary diffusing capacity of nitric oxide, I think it's important to discuss, well, where did pulmonary diffusion capacity for nitric oxide start? How did this all begin? And so I'll give you a little bit of history. And I'm going to summarize the history of DLNO from one of the gurus, or a couple of the gurus themselves. They wrote a article in Respiratory Physiology and Neurobiology about the history, in one of the special issues in 2017 on DLNO. So we're going to talk a little bit of history. Why is nitric oxide an excellent transfer gas? We're going to talk a little bit about the physiology. And then I'd like to talk about two different theories of diffusion. One you and I probably know very well is the Rowton and Forster model of diffusion. But then recently, there's another a time-based theory of diffusion, and I think we need to understand, or at least get a grip on, a little bit of these theories before we move on into understanding if and how DLNO can be used on top of DLCO to improve prediction and classification of cardiopulmonary disease. And so that is the, why we here is to kind of talk about why two is better than one.
View this full video at atsnow.thoracic.org.